Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today this is the 15th lecture of grade 9. The chapter name is Periodic Table and Periodicities and the topic name is Atomic Radius, its trends and the Covalent Radii. First of all, periodicity of properties. What is periodicity of properties? The pattern by which there is repetition of the properties in all the groups and the periods after a certain interval. Means the properties will repeat after a certain interval of time. All the properties, whether it is ionization energy, electron affinity, electronegativity, all the properties are repeat after a certain interval of time. Then this is called as periodicity of properties, or the pattern of repeating properties at regular interval is called as periodicity. This is the repetition of the properties in the different groups and periods of the periodic table when the elements are arranged in the increasing order of their atomic numbers. So the periodic properties are due to the electronic structure of an atom, that is due to the atomic numbers. It depends on the number of electrons. Electronic structure explains the observed trends in atomic size, ionization energy, electron affinity. Today we will study the atomic size, atomic radius and the covalent radius. The electronic shells. Electrons in successive shell means when the number of electrons are increasing, it means that the number of shells will increase. So the electrons in successive shells produce maxima in the electron density at increasing distances from the nucleus. The inner electronic shells are called as core, while the outermost shell are called as valence shell. You mostly use the word outermost shell or the valence shell. This is for the outermost shell, while the inner shells are called as core shells. Next is atomic size. The atomic size refers to the distance the valence electrons are from the nucleus. The atomic size means the distance of nucleus from the outermost shell. As the atom is found in the isolated form, it means that it has some particular size. But when that atom is combined with any particular other atom, then the size depends on both the atoms. So when the atom will found in the combined state, it means that the size will change. So an atom can combine with one or more different atoms. So in isolated form it has different size, but in combination with other atoms the size will change. The atomic size of an atom is expressed in terms of atomic radii, covalent radii and ionic radii. So basically, the valence electrons are involved in reactions and they determine size. Two factors affect size, that is nucleus and the balance between attractions and repulsion in the atoms. So basically, the atomic size is the distance of nucleus from the outermost shell. Greater the distance, greater will be the atomic size. Less the distance, less will be the atomic size. And when atom is found in the combined state, then the size will be different as compared to the atom that is present in the isolated form. Now atomic radius. What is atomic radius? It is same as the atomic size, that the distance of nucleus from the outermost shell or the distance between the nucleus and the valence shell of the atom is termed as atomic radius. That how much distance outer electrons or outer shell is present from the nucleus. So the atomic radius is represented by the small r. The atomic radius is directly proportional with the number of shells. Means atomic radius is basically the atomic size. Greater the distance, greater will be the atomic radius. Smaller the distance, smaller will be the atomic radius. So it depends on the number of shells. Atomic radius is directly proportional to the number of shells. The atomic radius can be expressed in nanometer and picometer. The nano shows the power 9 while the pico shows the power 10. So the nanometer is 1.0 multiplied 10 raised to power minus 9 meter, while picometer value is 1.0 into 10 raised to power minus 12 meter. Here you can see in this diagram that we are going from top to bottom in the group. We can see that the atomic radius gradually decreases. increases. This is because of the increase in the size of atom. So when the size of atom is increasing, it means that the atomic radius is increasing, because distance is directly proportional to the atomic radius. Greater the distance, greater will be the atomic radius, and smaller the distance, smaller will be the atomic radius. So here the distance between nucleus and outermost shell is increasing one by one in elements. So as the distance is increasing, atomic radius also increasing. So in group, that is from top to bottom, the atomic radius increases. Atomic radius trends in group, I have told you that from top to bottom the size of atom gradually increases, and when the size of atom increase, it means that the distance of nucleus from the outermost shell increase, and when the distance increase, it means that the size of atom increase. The size of atom increase affects the atomic radius. So the distance is directly proportional to the atomic radius. The distance increase, atomic radius increase, and the distance decrease, atomic radius decrease. Periodic trends, that the trend in period from left to right, the atomic radius decrease. As in the period, the number of electrons increasing. As the number of electrons increase, the number of protons also increase. It means that the positive charge also increase. This positive charge pull the number of electrons towards the nucleus. As more electrons move towards the nucleus, means distance is decreasing. When electrons will move towards the nucleus, it means that the distance is decreasing. It doesn't go far away from the nucleus. So when electrons come nearer to the nucleus, it means that the atomic radius will decrease. Atomic radius of the group 1 element in the group 1, as the size of atom gradually increases, which is directly proportional to the atomic radius. So the atomic radius increases from top to bottom. Now the covalent radii. What is covalent radii? The one half of the distance between the nuclei of two similar atoms of the same molecule containing a single covalent bond. What does it? It means that we have two atoms, and two atoms are similar. First of all, we take one atom, it has one nucleus. Then the second atom, it has the second nucleus, the two nucleuses. Now we take half distance from one atom and half distance from another atom. That one half of the distance between the nuclei of two similar atoms, we will measure it from the nucleus to the edge. And likewise in the second atom, we will measure from the nucleus to the edge, not the whole 180 degree. So we are measuring only 90 degree, means the half distance. The half distance from one atom and the other half distance from the other atom. And this forms a single covalent bond. So that radii is called as the covalent radii. Therefore, the bond distance between the two atoms, for example A and B, is the average of the length A prime and the B prime. For example, we are taking A and B atoms and we are measuring distance in atom A as A to A prime, and we are measuring distance in the atom B as B to B prime. So the average of the length will be A prime and the B prime, and the bond between A and B will be the single covalent bond. So the size of atom is measured by its covalent radii, the distance between the nucleus and its outer electrons. Looking across the period, as we know that from left to right also the electrons are pulling nearer to the nucleus, so the covalent radius will also decrease. As we move left to right, we are adding a protons to the nucleus and an electron to the outermost energy level. So by adding proton, it will pull electrons to the nucleus. Lithium atom has less electrons as compared to the fluorine atoms. So the lithium atom has less covalent radii as compared to the fluorine atom. So covalent radii increasing. The lithium atom has a smaller nuclear charge than neon, and so a larger covalent radius. The fluorine's greater nuclear charge pulls the outer energy levels in closer. In lithium, there are less number of electrons, so there is less probability of that electron to come nearer to the nucleus. While in fluorine, there are more number of electrons. It has more nuclear charge, that is more positive charge, so it will attract more electrons towards the nucleus as compared to the lithium, which has less nuclear charge and it cannot come close the electron to the nucleus. So the radius of fluorine will decrease after the pulling of electrons toward the nucleus, while the atomic radius of lithium will increase. Thank you so much.